Alright, you should be at gotomath.com. If you're not, get there. Okay, we're working some calculus problems. And of course, there's a little chat window here. You can chat live with me if you want. Alright, we are down here at infinite limits, and we're in this section here. We're looking at this function, h of x is equal to 4 over x. We want to find all vertical asymptotes of the function. And we can do that. Let's clear that board. That's some stuff left over from the last problem. Alright, let's look at this. It was, what was that? F of x is equal to 4 over x, I think. My God. Ooh, it's h of x. Alright, well, fx, h of x, right? Same thing, pretty much. Okay, we'll say h of x. Let's go over here in this particular problem. Whoa, that guy. Wow, that's something else there. If we were to graph 1 over x, graph it out, it looks something like this. Okay, I know we're a little slanted here, but you get the idea. The question, so that, as you can see here, the vertical asymptote is the y-axis, and we'd say the vertical asymptote actually is x is equal to 0, right, in this one here. Well, we have this number other than 1 up here. Well, we got the number 4 instead of the number 1, but the graph is pretty much going to be the same thing, okay? The question is to find a vertical asymptote. We want to set the denominator equal to 0, and this has been solved for x. Well, that's pretty easy. All we have to say now is x is equal to 0 is the vertical asymptote, is x is equal to 0. Now, if you took 0 and plugged it into the numerator and got 0, well, then this wouldn't be a vertical asymptote, alright? It's whatever number we can plug into this thing and only get 0 in the denominator, alright? Okay, let's x equals 0. So that's pretty simple. So you want to make sure you click on this button right here to get this problem to come up. We're talking about finding vertical asymptotes of the function. Now this is the section infinite limits, and I guess I'm just going to go ahead and add some stuff to this. If we were taking the limit as x approaches 0, let's say from the left of 4 over x, so we would be coming in from the left, right? And what's my y value going towards? As I get closer and closer to 0 from the left, my y value is going to negative infinity, all right? Now I know your limit should be equal to a real number here, but just in this sake, this is what we're saying. We're putting negative infinity over here to the right of the equal sign, even though your limit should be equal to a real number, and this is definitely not a real number. Let's do the limit as x approaches 0 from the right hand side. As you can see, as we get closer and closer to 0 coming in from the right hand side, right? What's my y value approaching? I should put 4 over x right here, I guess. Well, my y value is approaching positive infinity. It's going off to positive infinity. All right. So when we talk about infinite limits, this is what we mean. Okay, this is what we mean. There is another concept here that and that's limits at infinity, which is not vertical asymptotes but horizontal asymptotes. Limits at infinity. All right, don't want to get those two things mixed up here. But we're talking about infinite limits. In other words, what is the limit going to? Okay. What else? I don't know. What else could I mention about this since I've got just a tad bit of time? Also, in the previous section, we talked about continuity. We can see that this function is not continuous at x equals 0, right? We got a non-removable discontinuity here. Okay. What else? I guess that's enough. That's enough for now. Remember, here, click on this and practice your problems.